Hello friends. So in the last class we have discussed about the continuity. I think I have started with the exercise examples. Now here see we are not going to deal with all the questions from the exercise. Some randomly I have selected, okay, but whichever the examples I am solving, the similar type examples are there in the exercise, so you can solve those. Okay, so let us take the next question. Okay, the next question is find find all the points of all the points of discontinuity, all the points of discontinuity for the following functions. Okay, so in that first function is f of x is equals to f of x is equals to 2x plus 3 if x is less than or equal to 2, 2x minus 3 if x is greater than 2, if x is greater than 2. Okay, see I told you that if the function is given and the continuity point is not mentioned, means at x is equals to, if it is not mentioned, then always this problem can be solved in three steps: c is less than, c is greater than, and c is equals to. Okay, so first you have to write, I told you in the last class also, that is you have to write it first clearly. The given function is defined for all points in real line, or I can say in real number. So you have to assume one real number. Now let c belongs to R be any real number. Let c belongs to R be any real number. Now first case, c is less than 2, that limit point you have to choose it. C is less than 2. Okay, see I told you again, c is less than, for c is greater than, you have to use the first definition of continuity. That is, first you have to find f of c, which is equals to, which condition I have taken, for less than 2. See in the function, for less than 2, what is the function? 2x plus 3. But in the place of x, what we are having? C. So your function becomes what? 2c plus 3. 2c plus 3. Okay, and limit x tends to c, f of x is equals to limit x tends to c. Again, f of x is what for less than 2? It is 2x plus 3, which is equals to, substitute the limit as x tends to c here. So answer is 2c plus 3. So therefore what? The f of c and limit value both are same. So therefore limit x tends to c, f of x is equals to f of c. So if both are equal, then f is continuous, means given function is continuous for all points less than 2. For all points less than 2. This is your first condition. Okay, next now we have to take second condition, that is what? Greater than 2. Greater than 2. I think I will drop this part. So I will take it here. If c is greater than 2, okay, first we have to check f of c, which is equals to, now for greater than 2, function is what? 2x minus 3. But what is x here? C. So it is 2c minus 3. And limit x tends to c, f of x, which is equals to limit x tends to c. For greater than 2, f of x value is what? 2x minus 3. 2x minus 3. Now put the limit as x tends to c here. So it is 2c minus 3. Again f of c and limit value is same. So therefore what? Limit x tends to c, f of x is equals to f of c. And therefore what? F is continuous, okay, for all points greater than 2. For all points greater than 2, okay. So for first condition it is continuous, for second condition also it is continuous. But now third condition will decide whether this function is continuous or discontinuous, okay. Now I will take the third condition. Third condition is what? At c is equals to 2. At c is equals to 2. I will write it here. At c is equals to 2. This is your third condition. So whenever you are taking the third condition, you have to check it with second definition of continuity, that is LHL, RHL. Before that you have to find it f of c. But c value is what? 2. So f of 2. Okay. Now for equals to 2, where it is equals to 2? Equals to 2. Function is what? 2x plus 3. But here x is what now? 2. So 2 to the 4. Okay. I will write it here. 2 to the plus 3. So 2 to the 4. 4 plus 3 is 7. Okay. The next, you have to find LHL. Limit. What is the definition? Limit x tends to c minus f of x, which is equals to limit x tends to 2 minus your c is what here? 2. F of x. See, I told you LHL means always less than. So for less than 2, function is what? 2x plus 3. Substitute the limit as x tends to 2. So it is how much? I think you will get 2 to the plus 3. 2 to the plus 3. So which is equals to what? 2 to the 4 plus 3 is 7. So LHL answer is also 7. Next you find out RHL. RHL is equals to limit x tends to c plus f of x. This is the definition. Now put the values. Limit x tends to 2 plus RHL means greater than, and for greater than 2 function is 2x minus 3, which is equals to, now put the limit is x tends to 2 here. 2 to the minus 3. 2 to the means x, in the place of x I have put 2, so 2 into 2 and minus 3 as it is. Now 2 to the 4, 4 minus 3 is 1. Okay, so what about LHL and RHL? What about LHL and RHL? They are not equal. They are not equal. Therefore what? F is discontinuous. F is discontinuous at c or x is equals to 2. At x is equals to 2. Okay. We will see next question. I hope you understood this. Okay. I will solve 2 more questions of the similar type, and in the next video you will get some different type of examples compared to the today's class. Okay. So let us have the next question. F of x is equals to x cube minus 3 and this is x square plus 1. If x is less than equals to 2, if x is greater than 2. Okay. So again as usual we have to write that first sentence. Okay. What is that first sentence? Clearly the function is defined for all the points in the real line. Okay. After that you have to write one more sentence is what? Let C belongs to R be any real number. Be any real number. Okay. Then you have to follow with the cases now. If C is greater than 1, or you can take first one is C is less than 2 because your limit point is 2 here. If C is less than 2, so first we have to check f of C. So for less than 2, function is what? X cube minus 3. But x is what here? C. So it is C cube minus 3. And limit x tends to c, f of x is equals to limit x tends to c for less than 2, function is x cube minus 3. So put the value as c, so it is c cube minus 3. Okay, so therefore if you observe, limit x tends to c, f of x is equals to f of c. Both the values are same. So therefore f is continuous. Okay, f is continuous for all points less than 2. For all points less than 2. Okay, next, if c is greater than 2. If c is greater than 2. So for this, f of c is equals to, okay, c for greater than 2 function is x square plus 1. But in the place of x I am having c. So it is c square plus 1. C square plus 1. Okay. Now you have to check one more definition, that is limit x tends to c, f of x is equals to limit x tends to c for greater than 2 function is what? X square plus 1. Now put the limit is x tends to c, so answer is c square plus 1. Answer is c square plus 1. Okay. So therefore if you observe, f of c and limit value is same. So therefore limit x tends to c, f of x is equals to f of c. Okay. If it is equal, then what? F is continuous for all points greater than 2. For all points greater than 2. This is second condition. Now we will check third condition. Okay. For that I will rub this first part. The third condition is what? We have to take at c is equals to 2. C is equals to 2. So at c is equals to 2. So first we have to find f of c. That is f of 2 is equals to. Okay. Now equals to 2. Function is what? X cube minus 3. But your x is what now? 2. So it is 2 cube minus 3. 2 cube is 8. Minus 3, answer is 5. Okay. Then we have to check LHL. Limit x tends to c minus f of x, which is equals to limit x tends to c minus, sorry, c is 2, no, here 2 minus, LHL means less than, for less than 2 function is x cube minus 3, so which is equals to, put the limit as 2 here, it is 2 cube minus 3, again the answer is 5. Answer is 5. Now RHL is equals to limit x tends to c plus f of x is equals to limit x tends to 2 plus, okay. So RHL means greater than 2. For greater than 2 function is x square plus 1, which is equals to, put the limit is 2 again, that is 2 square plus 1, so which is equals to 4 plus 1, answer is 5. Answer is 5. So if you observe, LHL is equals to RHL is equals to f of 2. All the three values are equal. So therefore what? F is continuous. F is continuous at c or x is equals to 2. So there is no point of discontinuity in this problem. There is no point of discontinuity in this problem. Okay. I will take one more question. Next is f of x is equals to x to the power 10 minus 1 and x square. If x is less than equals to 1, if x is greater than 1. Okay. Now again the first sentence as usual you have to write clearly the function is defined for all the points in the real line. Okay. And then next sentence is what? Let C belongs to R be any real number. That is fixed for all the examples of such type. Then we have to take first condition, if C is less than Now your limit point is 1, so less than 1. So first we have to check it f of c. So f of c is what? For less than 1 function is x to the power 10 minus 1. So it is c to the power 10 minus 1. And limit x tends to c, f of x is equals to limit x tends to c for less than 1 function is x to the power 10 minus 1. Substitute the x value is c. So c to the power 10 minus 1. Therefore, okay, limit x tends to c, f of x is equals to f of c. Both are equal. And therefore what? Conclusion, f is continuous for all points less than 1. Okay. Second condition, if c is greater than 1. So again for that you have to check it f of c, which is equals to, for greater than 1 function is x square, so it becomes c square. And limit x tends to c, f of x is equals to limit x tends to c, f of x is x square. Put the limit as x tends to c, and it is c square. Okay. So therefore, again both are equal. So therefore, limit x tends to c, f of x is equals to f of c. Therefore, what? F is continuous. Okay, for all points greater than 1. For all points greater than 1. Okay. Now we will check the third condition for c is equals to at c is equals to 1. Okay. So first we have to check f of c, which is equals to c is 1 here. So f of 1. So for equals to 1, what is your function? X to the power 10 minus 1. But x is 1 here. So that is I think 1 to the power 10 minus 1. But as you know, 1 to the power anything is again 1 minus 1. Answer is 0. Okay. Then you have to find LHS. Limit x tends to c minus f of x is equals to limit x tends to 1 minus LHS means less than. For less than it is x to the power 10 minus 1. Put the limit as 1. Okay. 1 to the power 10 minus 1. Answer is 1 minus 1 is 0. Okay. Now RHL is equals to limit x tends to c plus f of x is equals to limit x tends to 1 plus RHL means greater than, and for greater than function is x square, so which is equals to, put the limit is x tends to 1, so it is 1 square, which is equals to 1. So therefore LHL is not equals to RHL. Therefore what? F is discontinuous at c or x is equals to 1. C or x is equals to 1. Okay. So these are some examples I have solved it. In the next video we will see some different type of examples. Thank you.